Okay, so here is another example on the current under the magnetic field. So, so we have a wire and conductor. Those are given the mass per unit length as m/L equals 0.04 kilogram per meter. And this one is within the magnetic field of 3.6 Tesla. And so they ask you to find the current in this conductor that must exist for the tension in the supporting wire to be zero. So this is a supporting wire. So if the tension is zero, so we are supposed that we have no supporting wire at all. Okay, so that all the forces in the system should just come from the gravity mg and should just come from the force Fb from the magnetic field. Okay, so in order to find the Fb and the direction of the current, we use the right hand rule again. Okay, but now if we don't know the direction of the current, using the right hand rule, the thumb is representing the Fb or the force. And normally for ILB, L cross B, so the first parameter L will be represented by the index finger. So this is L. And then the B will be the direction of magnetic field, which is going into the screen. So that is so L, this vector, must have the same direction as the current. Okay, so we can see from this picture that the current must be in the direction to the right hand side. Okay, so that is the answer for the first part. So using the right hand rule, we can, if we know F and if we know B, we can find the direction of the current by using right hand. And then when we consider the equilibrium, okay, we have the magnitude of Fb and we have the mg. So the magnitude of Fb from IL cross B will be ILB, because in this case, L is perpendicular to B. So when L is perpendicular to B, ILB sine theta or sine 90 degree will be just ILB. Okay, so that is the ILB on the right hand side and ILB on the left hand side and mg on the right hand side. So finally, the magnitude of the current I can be written in terms of mg over lb, in which m over l is already given as 0.04 kilogram per meter, and then times by g, which is 9.8 meter per second square, and then divide by the B or the magnetic field. Okay, so this is already m over l, so l is finished. So B magnetic field is 3.6 Tesla. Okay, so after the calculations, we should get the I or the current as 0.109 ampere, and that's our answer.